Hey guys, so today you and I are going to talk about second guessing yourself. So let's get into it. So the question in question was, Frederick, how can you make decisions when there are multiple solution options without second guessing yourself? Well, you can't, and you shouldn't. If you're not second guessing yourself or wondering if you did the right thing or not, uh, then you don't reflect enough on your decisions, and you should be very careful with that. People who act with absolute certainty are dangerous. They're damn dangerous for themselves and for other people as well. So but there is a difference between second guessing yourself and sort of reflecting on how you could have done things better and so forth. And well, let's call it reflection, personal reflection, as opposed to second guessing yourself, because you have to also be able to stand by the decisions that you have made. In other words, if you have no clear option or you have multiple options, there are a few things that you can approach can do. Like the way that I usually try to do it is that if I don't really know what the next step is going to be, then I try to figure out what is the most adjacent step that I can take to figure out what the next step is going to be. In other words, I'm not trying to make a decision, I'm trying to get to a point where I can make a decision. And that's something that when you do leadership things or so forth, that's sort of what you have to do, in my opinion, at the very least. And if you're running a team or whatever you're doing, uh, you don't always know exactly how the end result is going to look, or like how you should do do a specific thing, and then you do a experiment. You try something out at small scale. This ties into one of my favorite, or it's my personal belief that the most important rule to follow in software development is to write disposable code, because code always changes and you don't always know how everything's going to look at the end of things, which means that you have to create solutions that are in of themselves isolated enough, well working enough, that they can be used effectively within a grander scheme of things, or like fit into a larger system, but they have to it has to be possible at the same time to decouple them and throw them away if they're not performing any longer, or like if they don't fill the requirement or something like that. It is when you couple things to the point where it's difficult to throw stuff away, where you're more likely to start seeing rot within the system. Because if you have, it's sort of like mechanical engineering in a sense as well. If you have a faulty component and you can't remove that faulty component, then everything around it has to change in order for that faulty component to, not be over exerted or something like that, so it breaks or so forth and so forth. So it actually cascades. Where, what is it that they say? The chain is only as strong as its weakest link, sort of thing. Exactly that sort of stuff. That's the first and foremost thing. And so by simply making a small experiment and figuring out what your options are, the more likely you are to make a good decision. And then the second case is, as I've said, you have more than one option, and then it's really down to weighing pros and cons, and this ties into your experience as a software developer and how good you are at predicting what's going to happen next. And usually the better you understand both the software, like the coding, and the people who do the coding, the better it's going to be for you to make a decision. A classic one that I usually see in the more senior experiences is that they realize that there are many ways to solve a problem. Like you can pick different tools for a specific job, and what they usually will say is that well, I know about A, B, and C, and these are really, really awesome, and I mean, I enjoy working with them, but I also I try to remember that it's not just me who's going to work on this code, and so I usually go with D because that's the option that is most accessible, for example, to the other developers who are working, and then they usually motivate why that is a good decision, because it's not always a good idea to create something simple just because. In some cases you have to go with something that is more advanced, because, and sort of buy the fact that people are inexperienced with it due to technical limitations or performance or other sorts of factors, but on average that's the sort of mindset that you want to keep with you when you're trying to figure out what options to go with. And so once you have informed yourself of, all right, these are my options, usually it helps a lot if you discuss it, like crowdsource the thing. That's what I usually do when I am not 100% sure if I should do A or I should do B. Usually what I do is I'll call a rubber duck session with my team, depending on the scope. Of course, it might be one developer or it might be all of them, depending on how big it is. And I say, all right, what do you think, guys? This is my problem. And then you sort of present like, these are the options that I can see, and then you have an open conversation that usually gives you some idea of one approach over another. One of the an example of when I've done this, that I was very happy with the outcome, because it turned out that I was wrong, but I was wrong in the right way, which made me happy. I had a discussion with a software team a few months back, where we basically had the requirement on us to put together a monorepo which would host multiple different versions of applications, and we had standardized our tech stack. In this case it was on React, and so the question arose, okay, so how do we make all of these different repositories comply to the React, like this ecosystem, and run within the same platform? Because these are projects that are in multiple stages. Some of them are going to be greenfield, they're going to start from scratch, and some of them already have existing code. But we can assume that they're all React related, right? Or we thought so, at the very least. At the time we thought so. And so my first idea was, all right, let's just create a shared server. Let's pull together a shared Next.js server where the only shared, the only thing that each sub-project is just a set of modules and routes that are defined with each module, and we simply import them and treat it as a kernel pattern, basically, where the server is just the kernel, and each team injects their own routes, and that's it. So they get their own namespace or something like that, and then they all run within the same server instance. And so I thought that could be a good idea, but I also knew that that's risky, because you're basically tying everybody together into the same code. Like they can't have any deviations. Now we don't want that, but it doesn't necessarily mean that we can. That's a good idea. There are other ways to enforce consistency across multiple projects, and so one of my coworkers says to me, "Oh well, why aren't you just putting them all in different? Like maybe it's better to just have different Docker containers, and then, have each of the projects let's have the API gateway just direct to each individual pod, and then we just leave in the same repo." And I thought, well, that sounds good, but at the same time that also increases the likelihood that we will send duplicate information, and it increases the amount of JavaScript code and so forth for the customers and so forth. And so I said, you know what, let's start with the server thing, and because the cost of us migrating is so low, and let's see how it goes. And then we talked it through, and after we tried my approach, it turned out that I was wrong, because just a few weeks later we realized that there was a product that was going to be join the platform, but there were so many incompatibilities between the products that they couldn't just jump in, which is a problem, because if they can't just connect to the project and be part of the server, they're going to have to do all this migration and all this fixing, and which is going to, they're not going to be able to run as part of the system for quite some time. And so it turns out that the Docker solution was a better solution from that angle, but we didn't know about it until that point, if that makes sense. But due to the fact, as I was saying, due to the fact that we had made these investments into making sure that if we wanted to change our minds about this, it was easy. Because there was we could go one or the other way, but the cost of migrating is so low that because you should always remember that, guys, you can always migrate. It's more of a question. It's usually a question of how much is that's going to cost you. That's the main thing, I think, for you to remember if you want to assure yourself a little bit about your choices. What is the cost of undoing this is the primary thing to think about. So what I want you to take away from this is that if you want to make decisions and not second guess yourself, I would suggest that you at least reflect on the choices that you make, because absolute certainty is not a good thing. It's not a trait of a personality trait of a wise person. It's the personality trait of a zealot or a well, let's say other types of people. So first and foremost, try to think in terms of how can you inform yourself as much as possible about what decision should probably be the best one. And when you have multiple choices, try to discuss them with your coworkers, try to crowdsource them, get some feedback on them, and if at all possible, try to see how you can do a small proof of concept or an experiment to give you enough information to know if this is going to work or not before committing, going for all in. Because if you can reduce the cost of making a mistake, then it's like, then just go for it. Then second guessing yourself is not much of an issue now, is it? Have a great day.